Okay, all right. Well, I'll stop talking very shortly. So Melissa and Carlos can have all of the time. I'm sorry, I'm backlit now. I wasn't backlit before, something happened. But welcome everybody. Thank you for coming to the UC San Diego Huizhou Data Science Innovative Data Science Industry Partners session. That's a mouthful. I'm really excited today to have two of our guest speakers. Carlos Gomez is a data scientist at Apple right now, and Melissa Smith is Melissa, head of AI at Deloitte. Is that right? What's the right way of calling your title here? Is that a short enough and appropriate?
Yeah, that's perfect.
I guess I can give a quick introduction of myself. Oh, Melissa, can you mute again really quick? Sorry, the echo's pretty loud. My name is Bradley Voytek. I'm a professor at the Huizhou Data Science Institute at UC San Diego. I'm in the Department of Cognitive Science. I run a neuroscience research lab that combines neuroscience and big data science approaches. I helped set up the undergraduate data science program here at UC San Diego back in 2017, so we're a little over 2 years old. We just graduated our first cohort of data science undergraduates. We have about 70 people graduated this round. We have about 700 undergraduates already enrolled as data science majors, which is now one of the, I think, top 10 largest majors on campus. That's pretty quick for 2 years. And I also helped set up the Huizhou Data Science Institute. So the Institute is a collaborative organization of over 100 faculty, about 30 core faculty right now, ranging from places like cognitive science, which is my domain, statistics, mathematics, computer science, oceanography, you name it, there's probably a professor involved in the Data Science Institute, which really speaks to the breadth of data sciences right now. And similarly, our first graduating class of undergraduate data science majors, none of them could have come in because it's only 2 years, so they all transferred into the major from different programs, and we have a similar breadth. And one of the important characteristics of the undergraduate data science program is that the undergraduates get hands-on data science experience. I have worked in industry myself. Formerly, I was the first data scientist at Uber, where I helped set up their data strategy back when it was an 8-person startup called UberCab in San Francisco. And I found that one of the key characteristics of successful data scientists that we ended up hiring was not skill in machine learning and AI and things like that. You have the necessary technical skill, but one of the core critical skills was data creativity and thinking about problems from a data first perspective. And so we really worked hard to build an organization that could teach students those kinds of skills. And critical to that is actually working with real world data. And that's where our industry partners come into play. So having our data scientists get actual practical hands-on data science experience. And so with that preamble, I'm going to stop talking so Melissa can unmute and the echo will go away. And I'd like Melissa and Carlos to introduce themselves, and then we'll start with the chat.
Go ahead, Melissa.
Melissa Smith. I work at Deloitte Consulting. We are focusing on AI data science. We've got the industry relationship with UCSD, and what we've been focusing on right now is the intersection of commercial AI data science and government. I spend a lot of time in the government practice, helping state and local and then federal government look at different unique ways to use AI and data science to solve some of their bigger business problems. COVID has really created a lot of interesting opportunities for us, and so we've been spending a lot of time focusing there and excited to be a part of this.
Hello, everyone. My name is Carlos Gomez. I'm currently a senior director of machine learning at Apple, but I started just a few weeks ago. So I'm actually not here to talk about my work at Apple since I'm only starting to figure that out. I'm here to talk more about my experience in the past, which has included some time on Google working the search algorithm, then 7 years at Netflix driving innovation for the recommender system and the search algorithm. After that, 1.5 years at Facebook, managing their core data science team and also working on the newsfeed algorithms. I decided to go back to school and spent a couple of years at Stanford recently, learning more physics, theoretical physics in particular. My background is in a combination of engineering, science, mathematics, and I guess I started doing data science before the coin the phrase of data science itself, which is cool.
Fantastic. Okay, so we're pretty new here at the HDSI. Like I said, the HDSI, actually, I don't think I said this part, was founded also about 2 years ago in March of 2018. And the industry partnerships have actually really taken off quite quickly and been very, really positive interactions all around. The undergraduates really seem to love them. You know, I would hope that the converse is true. But because we're so new, it's really hard to, you know, look at long-term sort of returns on everything like this. Starting, I guess, with Melissa, in your experience working with Deloitte, which is very big on the creative thinking, consulting side of things, what do you see the value that undergraduates might be able to bring to something like that? And conversely, what do you see as your particular set of skills that undergraduates are lacking that you can sort of help them build?
Yeah, so really what we've been focusing on right now is the deep technical expertise. I think it is really where government is starting to spend a lot of their time. We've, as a consulting business, have a lot of domain expertise. So it's that intersection of the SMEs and the domain expertise and the students being able to have that niche capability that the government has really been looking for. It's available across commercial as well. It's being able to find those unique ways to solve business problems that has really been kind of transferring across different industries. So it's really the intersection of technical expertise and being able to translate that into business problems, business solutions.
It's a very hard thing to teach undergraduates. I give them an example of my early days at Uber, trying to come up with a data-driven solution to back in the early days, Uber was only in San Francisco. And we wanted to figure out which city does Uber launch in next. And so there's a lot of conversation about that. Everybody had opinions and sort of gut instinct. And being the data guy, I kept getting approached saying, well, you know, what's the data say? And I'm like, we don't have any data. How can I come up with an answer without any data? And so instead of sort of taking this defeatist, like we don't have enough data, there's a lot of data out there. There's a huge amount of data out there. And maybe no data set is perfect, right? It's not the ideal data set that you would have collected if you had several years and several $1 million. But there's enough data out there that are like in the orbit of what you're interested in that you can start to piece together a complete picture. And so I tell the undergraduates, you know, we encourage them in their projects to try and think about approaches using these multiple different attacks, right? Like, let's say, like, maybe we could scrape tweets about, you know, X, Y, and Z while simultaneously looking for publicly available data sets in these scientific journals. There's whole journals devoted to publishing, you know, cleaned, usable data sets. There's data.gov. There's so many different sources of data now. And so teaching students just how to think about those problems and how to find those data sets that might be appropriate. How do you tell good data from bad data? Yeah, so, you know, Carlos, you've worked in a number of industries and organizations now, you know, and I know, you know, you're very new at Apple. So I want to, you know, hear from, I guess, your experience at, you know, the big companies that you've worked with. What patterns have you seen or trends have you seen over the last couple of years from bringing in interns that maybe were more on the computer science and statistics side to seeing people more specialized in data science? Like, what are the skills that you find that they bring, and what skills do you find that they are currently still lacking?
It's a great question. I think training in statistics or computer science typically is too narrow, and people who are more impactful tend to have a more holistic mindset. And in particular, they think about the impact they have on humans and on the world and on society. They know science, they know the scientific method. They're very critical in terms of analyzing what is the impact of something they're going to change about the system, because they know they will impact the world. And in particular, the contrast can be, this is obviously generalizing, which, you know, is not always the best thing to do, but it is a contrast to people who have come maybe more from a computer science background, where in classes, unfortunately, they're typically given metrics that they're supposed to optimize. And I've actually had people ask me directly at work, you're not giving me the metric to optimize, you know, the equation. And I think that's ridiculous, because there isn't a magic metric. And in fact, what I have seen is that people who blindly optimize a metric thinking that they're doing a good thing simply because that metric is moving what they think is in the right direction, ultimately tends to have side effects that are important and quite negative. So again, I think it's more of a holistic mindset that includes the social impact of what you're doing, as well as the scientific method to not trick yourself into believing that the impact of what you're doing is limited and is not worth really understanding more deeply. You asked about interns, and I actually have not worked much with interns. In fact, I think it's great that there's an undergraduate degree at HDSI in data science, but I would encourage all your graduates to specialize further, at least to have an impact on the industry where I've worked. These large-scale algorithms that are interacting with hundreds of millions or billions of people, it is really not enough to just have an undergraduate degree. You can do analytics and help understand what's going on in a Python strategy, and that can be very impactful and important. But if they want to be building the actual algorithms, they need a lot more depth. So at least a master's degree, and they have to do an exceptional master's degree. And typically it's a PhD. In fact, many PhDs don't even have enough depth to do the kind of work that, I think is the critical, I guess, that is at the core of these products.
One thing I'm hearing that both you and Melissa said is, we refer to it often. I mean, many people do. It's the T-based learning, right? So you've got to have the breadth, and that's one of the tricks about data science is it could take you certainly more than 4 years of undergraduate data science education to get that breadth, while also simultaneously finding one domain to really dig deep in, right? And yeah, so we do at the HDSI, we are in the process of getting approval for like a 5-year combined undergraduate master's degree and potentially even PhD program in data science, specifically to allow people to get that kind of depth where needed. And like, not everybody wants to do that, right? And not every job necessarily requires that, arguably, but many jobs do. And so the students get to choose which area they can focus on to really dig deep. So every student has to do these capstone projects where they choose a depth focus. And that depth might be algorithms and databases, right? It might be on the statistics, machine learning, AI side. There's a question here from somebody asking, what's the distinction between AI, ML, and data science? AI, ML are tools that many data scientists use, but I would say they're very much distinct. But I'm very biased and bullish on data science being something different. So, I think AI and ML are tools that many data scientists will use, but I think data science is, if I have to, summarize it very concisely, how is it that observing and quantifying the world allows us to make inferences and predict the future about it? And that's like the fundamental philosophical basis of data science. And that is done using multiple heterogeneous data sets. So how do you take, if you're at pretty much any company now, how do you take text data? Let's say imagine that you're a social media company. People can write comments in text, status updates. They upload photos. They have geographic information about where they are when they did things. How do you take photo data, text data, video data, demographic information, their friendship networks, URL networks of websites that they link? How do you take all those different kinds of data sets and combine them to come up with like a single number to target the KPIs of interest, right? And so Carlos, going back to what you were saying, oftentimes students in AI and ML are taught, how do I minimize this error or something, right, on this data set? The KPI, the key performance indicator, is given to you. You know what the answer is. And one of the hard parts about data science, I think, is sometimes you don't even know what the KPI is, and there's many of them, and they're nebulous. And so how do you optimize many nebulous KPIs simultaneously using data sets that aren't the ideal data sets? And so, Melissa, when you're going into, on the consulting side, and you're talking about the technical aspects with the companies that you're working with, one thing that I find is very tricky is getting technical experts communicating effectively to non-technical stakeholders. And so, like, what are the tricks that you're finding when you're working with those kinds of, I guess, problems, issues?
Yeah, so it's a lot of storytelling. It's a lot of marketing and getting more towards the business solution as opposed to the technical solution. So you might be able to solve a problem using neural nets, but you're going to have a CEO or CTO or CDO that really doesn't understand what that means. So it is taking that conversation and pushing it towards how they're going to be able to understand it, consume it, so that you're not applying AI to a problem, you are just solving the problem, and it might just happen to have AI in it. So it's really reframing the problem, making sure that you do a complete readiness assessment of, are they ready to actually take this type of technology? They have the data, they have the infrastructure, they have security and all those things. And through the course of a series of conversations and a couple of art of the possible discussions that you have with them, you're able to kind of dissect what it is they're really asking for, reframe the problem, reshape it a little bit based off of what it is that they have access to. Maybe they have an AI problem, maybe they don't, maybe they think they do and they have ambitions to do computer vision, but they don't actually have any cameras. So it's really making sure that they know what business problem they're trying to solve and kind of creating the narrative around their problem, not so much around the technology.
That's a hard one, right? Because the technology is what gets so much attention, right? And so somebody. Go ahead.
Yeah, for sure. It's I want to do AI because it is the big buzzword, or I want to do, pick a technology, but it really may not be the problem that they're trying to solve, and it may not be worth the experience that they're going to have to go down and the road they're going to have to go down to solve it. So it's partnering with the right technical SMEs to really make sure that they're solving for the right problem.
Yeah, and there's, in my experience, companies that were like born in the data science era operate very differently and interact very differently with data than companies that are now leveraging data science in a way that they couldn't have before, right? Working with a lot of companies, it's a given now that almost every data that you're allowed to store, you should store because it could be useful later. It seems like. Whereas consulting with other companies, older companies that have been around for decades, it's still like a kind of a, the analogy is always like the slow moving ship, right? How do we start taking advantage of the data that we could be saving that we otherwise haven't thought about doing? And so again, a lot of these things are really difficult. There's quite a number of questions in the chat, so I'm gonna kick it back over to Carlos because a lot of them are about the sort of T-shaped skill sets and how much extra like education do you need in order to kind of think about these problems, right? The technical side is, again, I don't want to like de-emphasize it. It's so important and so critical, but at least in my experience, many problems that people think, to go back to what Melissa saying, should be solved with AI or like machine learning, don't necessarily need that. Like, you don't need that first, right? There's other problems and hurdles along the way that need to be addressed before you get like a really strong AI, big data, machine learning infrastructure in place. And so, Carlos, like in your experience, because you have a PhD, you've gone this route. Like, how did you end up going into the data science route? I guess, and learn the business side of things coming from the scientific background.
It's a long answer because it's been a journey trying to figure out where I can, have the largest impact, really. I think it starts with imagining a better world and then realizing what you're good at and then finding an intersection of the two. And like Melissa was saying, I do think that one needs to become an expert in the domain that you want to improve, as well as on the tools that are relevant. And machine learning is just one set of tools that can be helpful. But data science, you can think of it as more as a way of thinking. Again, thinking like a scientist. And that means you bring in opinions to the table of how you want the world to be. And then you have all this set of tools, experimentation, machine learning, and many others, like actual engineering, physics, understanding biology, energy. It really depends on the area, but I do think you need to get depth on, first of all, the domain that you want to improve. And then in addition to that, in the relevant data science techniques to be impactful. So for me, I was always interested and good in applied mathematics. And I did internships in consulting, business consulting at McKinsey. I worked in a hedge fund in New York for 3 months. I worked in semiconductor manufacturing, in a standard software engineering company. And I just found that neither of those felt worthwhile for me as a purpose in life. And somehow in 2008, when I was finishing the PhD and Google was thriving, the mission that they had at the time of organizing the world's information and making it freely available really resonated with me. I was using the product every day, and I could see that it had a lot of room to get significantly better. And it was also very obvious to me with the mathematics and the statistics that I have learned that those techniques should have been incredibly helpful in making their algorithms and their product better. So it was sort of like the intersection of imagining a better world and then the tools and the techniques that you're good at and your way of thinking that can accomplish finding the path where you think you can have an impact throughout your life. And that will be different for different people.
Speaking of that, I guess then, Melissa, what was your path then into this?
Yeah, mine is a bit abstract. I started my career in the Marines, and then moved over and flew drones for the Air Force for 10 years. And towards the end of my career in the Air Force, I recognized that the drone system is more of a data collection platform than a weapon system, or just a weapon system, and started seeing being able to use that data for humanitarian disaster relief type environments. As I was exploring that, I spent some time looking at startups and ended up creating my own startup, flying drones for the NFL and some law enforcement agencies. And as the FAA started making it a little bit easier for people to get drone licenses, we started partnering with Google to build algorithms to allow the drones to fly itself based off of the patterns that we are seeing on the field or on the ground. And that integration of the data collection platform on the drone and the AI algorithms that Google was helping us develop kind of created a whole new area of interest for me. Ended up selling that company and coming back to government service, looking at different intel agencies and some of their business problems, and being able to help them shape their solutions a little bit differently using AI. And now the firm's taken a huge investment internally in this technology and in this growth play. And I've position myself to be part of that internal investment and help our clients and our ecosystem partners do things in really unique ways.
This is something that's so fascinating to me, and I find is very hard to organically try and develop, which is everybody that I speak to that is a data scientist has come from a completely different direction. And I'm a neuroscientist. I did my PhD in neuroscience after doing my undergraduate in psychology, and learning. There's a question over here about career transitioners not having the most technical work experience background. I didn't really start getting into doing any kind of like serious technical work until later in my PhD. And I think everybody comes from a different background in that sense, right? And how do you organically grow an institute or an undergraduate educational program that teaches the utility of all of these different perspectives and how they come together? And Carlos, you were talking earlier about trying to use the data to solve problems that matter to you, to, I guess, try and summarize it, right? Like a big thing that comes up oftentimes is like ethics. And you both worked in very large companies that have like huge amounts of data, and ethics is something that comes up constantly. And like, how do you teach people in your organizations? And this is going to piggyback on a question here. Somebody asked about what are best practices for data governance and data strategy. We have almost every one of our classes, I would say, for the undergraduates has a data privacy and ethics component. And what I find is that so many of these undergraduates have this like hunger to work in problems that are like related to civic and social good. They want to use data science to do something good to help people and help the world, right? And you've got these companies that are, at the same time, you've got these massive companies that are like, we've got all this data, how do we use it to improve our product? And at least in my experience, nobody's like, how do we use our data to do something nefarious, right? Like everybody wants to do something good, right? And so how do you this is a really big question to end on. How do you work with these large data sets to try and solve problems that matter to you? And how do you see our future education shaping, or how do we shape the minds of future data scientists to like think about the scope of and scale of like, I guess the power that they might have? I don't know how to like phrase that. It's such a big question, but it's something that comes up over and over again. Anybody have any thoughts? I'm mostly trying to spur on something more clever than what I just said.
Well, I'm not sure I can help that, but I do think that's where the social sciences background comes in. And that's why it is important. And again, stressing that you need an opinion. There's this belief somehow that we should all be objective when we build these products. And in my experience, that's just a fallacy. There's no such thing as being objective. So you want to have experience describing what you want to achieve and arguing for why that is the right vision. And anyone who pretends that what you can do is purely objective, so let's say that the goal is to allow every word ever uttered by anyone to be distributed as widely as possible, that again, that's just not a goal. That ends up having so many consequences that can be detrimental, that again, it's incredibly important instead to educate people who can debate and describe what they think their vision for the area they care about will be. And there's no substitute for that. So I would say there's that, which is the vision part. And then there's the thinking like a scientist. And then there's the tools. And I think that's independent of the data. In many cases, like you were pointing out, you don't even have the right kind of data. But if you have the mindset of a scientist, you start by trying to understand really how something is working, how the area that you care about works, how the product works, how it is interacting with the world. And the more you understand that, maybe you need to collect more data, you need to interview people, you just need to think about it, and then develop an opinion for how you should change it, debate it with other people and stakeholders, and then ultimately define a path. And then at that point, maybe the machine learning will be helpful. But in my experience, again, that is, in a sense, the least important aspect, the machine learning. So it's really about developing a strategy and a vision and identifying what is the right path to pursue.
Half hour is actually almost winding up, so I'm going to let Melissa close it out here. But I want to let everybody know we will be in our virtual booth. If you go to the Sessions tab, you'll see the Huizhou Data Science Institute there, and we can sort of continue having some conversation over there in the virtual booth after this. But I wanted to give Melissa a chance here to give her thoughts.
So for me, it's all about kind of what Carlos was saying. It's the data, the methods, the tools, and the output. And you really got to concentrate on the output and making sure that you're solving the right problem. And I think ethics can be wrapped into each of those steps. And just making sure that the end user knows what is in each of those, the data, the method, the strategy, and just making sure that there's complete communication and transparency in everything that we're doing.
Yeah, I can't argue that. I think that's right. There's one question here, there's one comment here. It says DJ Patel said something yesterday about establishing a personal connection to the data points. I want to point out that DJ is a UCSD alumnus, and he's actually on the advisory board for the Huizhou Data Science Institute. So we're trying to put together a really good team of people that'll keep these things in mind, including the social sciences. Cognitive science at UC San Diego is one of the founding programs of the Huizhou Data Science Institute. That's my program. And it's in the social sciences. So we actually have a very heavy connection with the Institute for Practical Ethics here, which is a group of philosophers, ethicists, and people from the arts and humanities. So we try and take a very holistic approach to thinking about these things, because data aren't just data. They are generated almost entirely, the data that we care about, by people and social structures, and then we care about ourselves because we're largely narcissistic beings. And so trying to understand the structures that generate those data points that are oftentimes people is pretty critical. But anyway, I have to stop. I said I was going to let Melissa finish it off, and I just soapboxed, so I apologize. But I will hand it back over to Melissa in the virtual booth. So everybody, please join us over there. Thanks, everybody.